Hello again. Welcome to the first lecture in the video lecture series for Introduction to the Art of Programming Using Scala for Chapter 3. So up till this point we have been learning about kind of basics of computers, basics of kind of programming in general, and the command line. In this chapter now we're actually going to start working with Scala as a programming language. And learning a programming language is in many ways very much like learning a natural language. So we're going to start off fairly simple. We'll give you possibly a few phrases that you could repeat, and we have to start learning the grammar of how you put things together and the vocabulary, the definitions of various words. In fact, I'm going to describe in this video a lot of things that are actually very common to many different programming languages, including Scala, and I'm going to use an analogy that is specific, that is links it to natural languages. And while this analogy isn't perfect, I think that it's very helpful for most students to start to see how things fit together. At this point, I'm also going to start using terminals in my own workspace instead of in the Linux Mint environment. Of course, you can follow along in Linux Mint, and you can create subdirectories to work on things if you would like to. All of this will work just as well in that environment. So we saw last time that we can start up Scala just by running the program Scala, and that puts us into the REPL, the read, evaluate, print loop. So in this REPL, you are allowed to type in statements. Okay, now, so to understand what that means, we kind of have to talk about how things break down. So if you're learning a natural language, like English, and you're supposed to write a story, and that would be the equivalent of our total program. Short stories would be short programs, long programs would be novels. In fact, actually, long programs are typically much longer than any novel would be. And they're typically written by teams of programmers. Just like a story can be broken down into pieces, programs can be broken down into pieces, and there are certain terms that you need to understand to be able to talk about the structure of a program. So when you write a story, you break the story down into, it has, possibly it has chapters, it has paragraphs. The paragraphs are built out of sentences, and sentences are built out of words. Okay. We want to take those types of ideas and see how they translate into programming. So in the last video for Chapter 2, we wrote our first Scala program, and it looked something like this. Okay. I'm going to add one extra character here, a semicolon. This is a statement in Scala. It tells Scala to print something out. And this gets broken down. So just like if you were to write a sentence in English, that sentence would be made out of words. In programs, the smallest piece that has meaning in and of itself is what we call a token. So in a natural language, the smallest piece that has meaning is a word. If you break a word into pieces, if you insert spaces into it, or you start removing spaces between them, you can change the meaning of those words. In fact, most of the time you'll wind up with gibberish. The exact same thing happens with programs, but the smallest piece that you can't break apart is not referred to as a word, but it's referred to as a token. And in this particular statement, there are a number of tokens. One of them is the print line here. Another one is the open parentheses. The closed parentheses is also a separate token. The semicolon is a token. And then everything inside of the double quotes, including the double quotes, is a token. And we'll talk about these a bit more. When we put these all together, we get a statement. So a statement is very much like a sentence. It tells the programming language, it says, do this. It's the smallest kind of piece that has a complete instruction in of itself. The type of thing that you would need a sentence for in normal English. Now, just like in normal English, you have to end your sentences with particular types of punctuation, periods, exclamation points, question marks. In Scala, statements often, typically end with semicolons. We will see some statements that do not necessarily end with semicolons. But you might remember that the last time that we wrote this, when we put it in a script, I didn't type the semicolon. It turns out that works just as well. And the reason for this is that Scala does something called semicolon inference. If you get to the end of a line in Scala and it sees that a semicolon would work there and would finish off the statement and everything would be happy, it will add one in for you. That way you don't have to type it. This can be very helpful for beginners because it turns out that leaving out semicolons is a very common mistake for beginner programmers. You can put semicolons in if you want in Scala. It's generally not the recommended style. And there are some places where you would put semicolons. For example, if you wanted to put multiple statements on the same line, then you have to put semicolons in between them. But that also is something that we will not do very frequently. So we take these tokens, which are the pieces that we can't break apart, or that when we break apart they change their meaning, and we put them together to make statements. To show you that things are a token, if I put a space in the middle of that, this becomes gibberish. Scala doesn't know what we're talking about. If I put the space in a different location, I can actually get a different type of gibberish. What about putting in some spaces there? Well, this still works. This is still well-formed Scala, but I have changed the meaning of this. Okay, so now this is a fundamentally different token than what it had been before. And of course the parentheses are single characters, so it doesn't matter. What if I put spaces in between tokens? Okay, well, turns out that for the most part, Scala doesn't care. Okay, Scala doesn't care if you put white space in that, so not only spaces, but tabs. And in scripts, often carriage returns, you can hit enter, with the exception that Scala will start putting in new lines for you, or will start putting in semicolons for you due to the semicolon inference. Okay, so here I've spaced out all of the tokens. So the print line is a token, the parentheses, and if I were to put spaces into any of these other things, it winds up changing the meaning of this. Now, in English, you have words, and you use words and various punctuation to build sentences. There's kind of a level in between a word and a sentence in the English language and many languages, and that's something called a phrase. Okay, a phrase has a certain level of meaning. It's more meaning than an individual word has, but it doesn't necessarily constitute a whole sentence. Now, in some cases, it does. For example, the sentence stop is a single word, it is also a phrase, and it is a complete sentence. And that will happen in Scala as well. In Scala, kind of the in-between level is something called an expression. An expression is actually a very important thing in Scala, in many languages, but in Scala more than in some others. An expression is a grouping of tokens that has a value to it. So a statement can be executed. An expression can be evaluated. When you evaluate an expression, you get back a value. So to illustrate this, I want to put in a very simple expression. Okay, 56. And now, when I hit enter here, Scala evaluates this 56 and tells us something about it. 56 is a token. If I put a space in the middle of here, I change its value. It's no longer 56. 5 space 6 is something different. And when it evaluates this, it says that its value is 56, which is exactly what you would expect. But it also gives us a little bit of extra information here. It says res6 colon int equals 56. Every time you put in an expression to the RAPL, it evaluates it and it gives it a name. So in this case, the name res6 has been attached to 56. And in fact, if I type in res6, you can see it comes back and it's 56. And now the name res7 also refers to 56. This over here, so the colon is a separator between the name and the type. And this says this has type int. Okay. So that capital INT is special to Scala. All expressions in Scala have types, and it winds up being very important to the language and for your ability to program, for you to know the types of things. So we're going to look at a number of simple expressions here and see what types of what their types are. And this will introduce us to some of the fundamental types in Scala. It turns out that we'll learn later on you can make your own types in Scala, and so in a very literal sense there's an infinite number of types in Scala because you can always create a new one. But we're just going to cover some of the basic ones in this. Now this 56 here is not only a token, it's a special type of token. It's what we call a literal. And so a literal is a special type of token that has a value in and of itself. So the simplest expressions are literals. 56 is what we call an integer literal. Int is the type that represents things that you might think of as normal integers, with the provision that there are bounds on it. And we'll talk more about the bounds on those in the future. What other types are there, and what type of literals do we have? Well, integers represent kind of whole numbers, is how you're used to thinking of them, both positive and negative. So, for example, negative 56 is also an int. What if something has a fractional value? For example, 5.6. Well, 5.6 is also a literal, but you can see here that 5.6 has a different type. Okay, it's no longer an int. Now this is a type that is called double. And what a double represents is a more general number. The closest parallel for math would be real numbers, but once again there are limitations on what a double can represent. They can only be so big, they can only be so small, and there's kind of a finite number of them, which can lead to some interesting situations, and we will hit on those later on. But for the most part, we are going to use doubles if we have a value that is numeric and it isn't necessarily a whole number, and we're going to use ints for things that are whole numbers. We'll see there are some other options, but for the most part we're going to stick with those two. Those are our basic numeric types, and we can also combine these literals. So for example, 56 plus 4. So I can do that. I can also put spaces in here so that it's very clear. I have 3 tokens here. 56 is a token, plus is a token, and 4 is a token. And the result is what you would expect. 56 plus 4 is 60. Because both 56 and 4 are integers, this winds up also producing an int as the result. If I had 56.5 plus 4.3, I would get a double. Okay. What about 56 plus 4.5? Well, turns out that when you do this, when you add a double to an int, not all doubles are ints, but all ints are doubles. So it actually converts the 56 into a double and then adds the 2 and gives us back the result as a double. In addition to plus, you can do multiplication, you can do division, you can do subtraction. It's worth going back and looking at that division for a second. For example, what is the value 7 divided by, or let's go with an easy one, 5 divided by 2? Okay. You can all do that in your head, and immediately you probably say 2.5 or 2.5. And Scala says 2. I like to tell my students that in learning to program, you're going to revisit your elementary education a lot. And if you had recently come through 3rd or 4th grade, this would make perfect sense to you, because 5 divided by 2 when you were in 3rd or 4th grade is not 2.5 or 2.5, because you don't know what 0.5 means and you don't know what a half is. 5 divided by 2 at that level is 2 with a remainder of 1. You could only make 2 whole groups, and then there was something left over in the end. You called that the remainder. And I bring this up not only because when you divide integers, you get the quotient, the whole number value, but there is also another operator, the percent sign, that is read as modulo, and it gives you back the remainder. So 5 modulo 2 is, after you divide 5 by 2, you get a quotient of 2, but you get a remainder of 1. Okay, and so that will give you the remainder. And that operator winds up being really helpful to us in quite a few different situations, and we'll be using it a lot in the book. So, don't just gloss over it and say that's some math thing I don't care about. We will be revisiting that. What if one of them is a double? Well, if one of them is a double, now I'm not restricted to just having integers, and we get the result that you were probably expecting in the first place, that 5 divided by 2 is 2.5. But that only happens if one of them is a double. If they're both integers, you only get the quotient part. That gives you kind of a rough introduction to numeric types, the int and the double, and the operations, simple operations that we can do with them to put together expressions. Of course, you could also build larger expressions out of these things. Okay, you can play with this. You can basically use Scala like a calculator, and it will tell you the results of things. In fact, if you're doing things in courses or whatnot where you need a calculator, it might be good to get into the habit of bringing up Scala to get a little practice with it. There are other types as well in programming. So, for example, we saw our first example was print line hello world. And we said that the print line was a token, and the parentheses were tokens, and this hello world is a token. We're going to save the exactly what the print line is until later, but what about this hello world? Okay, well, this is another literal. This is what's called a string literal. Okay, so character data, when you think of text, that is typically stored in the type called a string. And here you can see that this winds up actually using the Java basis for Scala here. But just hello world in double quotes is a literal, it's an expression, and it comes out as hello world. You can also do some types of operations on strings. For example, when you do plus, it does concatenation. It sticks the two together to make a longer string for you. You can also do multiplication, in which case you get that string repeated multiple times. You cannot do subtraction. You cannot do division. Those really don't make any sense for strings. But addition and multiplication by an integer make sense. What happens if you do addition with an integer? Well, in that case, what happens is the 3 gets converted to a string. So this is the same as that, and then it does string concatenation between the two. Now, a string is, of course, made up of individual characters. What if I just wanted to represent the character h? There is also a type for that, and it is type char. And you can represent character literals with single quotes. Okay, so this single quote h represents the single character h. What happens if you do some math with that? Well, that's interesting. That says that apparently the character can be treated as a numeric value. What does 77 mean? Where did that come from? And it kind of implies that h is 72. We'll come back to that in the next video, and we'll show you how you can get that all characters have a numeric value associated with them, and you can find out what that is, and you can do arithmetic on it. This also is something that's very helpful to be able to do. So the types that we've seen so far are int and double for normal numeric types, string for text, and care for individual characters. There's one other type that we're going to use a lot here early on, and it is the type called Boolean. And the Boolean type, unlike all the others, so for example, there are lots of different characters, there are many, many, many different possibilities for strings or ints or doubles. The type Boolean only has two possible values, true and false. Okay, so when you have a value that is of the type Boolean, it will always be either true or it will be false. And we'll see later how we can build expressions that evaluate to Booleans. Those also are very helpful, and they allow us to do logic with things. So this was a brief introduction. I highly recommend that you pull up the REPL in Scala and play around. Start typing in some things, start trying to do operations on stuff, and see what comes out of it. See if you can figure out what types of conversions are really going on, and what happens when you do operations between different things. We'll come back next time, and we'll learn how you can call methods on objects of these various types.